Welcome to MindMap MCQ. In today's video, we will be learning about the fascinating world of earthquakes. We will explore what causes these natural phenomena, their impact on the planet and humanity. This video is perfect for your exam preparation. Stay tuned and make sure to watch till the end. Prepare, practice, prevail. 1. What is the point inside the earth where an earthquake begins called? Options are A. Epicenter, B. Fault, C. Hypocentre, or D. Seismograph. The correct option is C. Hypocentre. The point inside the earth where an earthquake begins is called the focus or hypocentre. It is the location within the earth where the strain energy stored in the rocks is first released, initiating the seismic waves that propagate outward and cause the ground to shake. 2. What is the point on the Earth's surface directly above the hypocentre called? The options are A. Epicenter, B. Hypercentre, C. Seismic center, D. Crust. The correct option is A. Epicenter. The point on the Earth's surface directly above the hypocentre is called the epicenter. It is the location where the seismic waves first reach the surface, and it is typically where the strongest shaking and most significant damage occur during an earthquake. The epicenter is crucial for emergency response efforts and for understanding the earthquake impact, as it helps to pinpoint the area most affected by the seismic activity. 3. Which scale is commonly used to measure the magnitude of an earthquake? The options are A. Mercalli scale, B. Beaufort scale, C. Fujita scale, D. Richter scale. The correct option is D. Richter scale. The Richter scale is commonly used to measure the magnitude of an earthquake. Developed by Charles F. Richter in 1935, this logarithmic scale quantifies the amount of energy released by an earthquake. Each whole number increase on the scale represents a tenfold increase in measured amplitude and approximately 31.6 times more energy release. While the Richter scale was widely used in the past, it has largely been replaced by moment magnitude scale for more accurate measurements of larger earthquakes. 4. What type of fault is associated with horizontal movement? The options are A. Normal fault, B. Strike-slip fault, C. Reverse fault, D. Thrust fault. The correct option is B. Strike-slip fault. A strike-slip fault is associated with horizontal movement during an earthquake. In this type of fault, the rock masses on either side of the fault plane slide past each other horizontally. There are two main types of strike-slip faults: right lateral or dextral and left lateral or sinistral, depending on the direction of movement relative to an observer. Strike-slip faults are commonly found along tectonic plate boundaries, such as the San Andreas Fault in California. 5. Which seismic waves are the fastest and travel through both solids and liquids? The options are S waves or secondary waves, B. surface waves, C. love waves, or D. P waves or primary waves. The correct option is D. P waves. Primary waves or P waves are the fastest seismic waves and can travel through both solids and liquids. They are a type of body wave that compresses and expands the material they move through, similar to sound waves. P waves typically arrive first at seismic stations after an earthquake occurs due to their high speed. Their ability to travel through various mediums, including the Earth's liquid outer core, makes them crucial for understanding the internal structure of the Earth. Waves can only travel through solids. The options are A. P waves, B. surface waves, C. S waves, D. Rayleigh waves. The correct option is S waves. Secondary waves or S waves can only travel through solids and are a type of body wave that moves material perpendicular to the wave's direction of travel, creating a shearing effect. S waves are slower than P waves and cannot pass through solids or gases, which is why they do not travel through the Earth's outer core. Their inability to move through liquids helps seismologists determine the Earth's internal structure, particularly the distinction between solid and liquid layers. 7. The intensity of an earthquake is measured by which scale? The options are A. Richter scale, B. Mercalli scale, C. Mohs scale, or D. Decibel scale. The correct option is B. Mercalli scale. The intensity of an earthquake is measured by the modified Mercalli intensity scale. This scale assesses the effects and severity of shaking experienced at specific locations, ranging from Roman 1, which is not felt, to Roman 12, total destruction. Unlike the Richter scale, which measures the earthquake's energy release, the MMI scale evaluates the earthquake's impact on people, buildings, and Earth's surface. It provides valuable information for assessing damage and planning emergency response efforts. 8. What is the main cause of most earthquakes? The options are A. Tectonic plate movements, B. Volcanic activity, C. Human activities, D. Gravitational pull. The correct option is A. Tectonic plate movements. Most earthquakes are caused by the sudden release of energy in the Earth's crust, typically due to the movement of tectonic plates. These plates are large sections of Earth's lithosphere that float on the semi-fluid asthenosphere below. When stress builds along the plate boundaries or faults, it can overcome the friction holding rocks together, leading to sudden movement and the release of seismic waves. This movement generates the shaking and vibrations felt during an earthquake. 9. What is a seismograph? The options are A. A device used to measure temperature, B. A device used to detect earthquakes, C. A device used to measure wind speed, D. A device used to predict weather. The correct option is B. A device used to detect earthquakes. A seismograph is an instrument used to detect and record seismic waves generated by earthquakes or other ground vibrations. It consists of a mass attached to a fixed base. When the ground shakes, the base moves, but the mass remains stationary due to inertia, causing a relative motion between them. This motion is converted into an electrical signal or graphically recorded on paper, creating a seismogram. What is a fault? The options are A. A break in Earth's crust, B. A volcanic eruption, C. A type of rock, D. A weather phenomenon. The correct option is A. A break in Earth's crust. A fault is a fracture or zone of fractures in the Earth's crust along which displacement has occurred. Faults form due to the tectonic forces that cause stress in the Earth's lithosphere. When the stress exceeds the strength of rocks, they break and slide along the fault plane. This movement can be horizontal, vertical, or oblique, leading to earthquakes. Faults are classified based on their movement: normal, reverse, and strike slip, each reflecting different tectonic settings and stress regimes. 11. Which type of fault is associated with the Himalayas? The options are A. Normal fault, B. Strike slip fault, C. Reverse fault, D. Ring fault. The correct option is C. Reverse fault. The Himalayas are primarily associated with reverse faults. These faults form due to the collision and compression between the Indian plate and the Eurasian plate. As the Indian plate pushes northward into the Eurasian plate, it creates immense pressure, causing the crust to thicken and the hanging wall to move upward over the footwall. This tectonic activity has resulted in the uplift and formation of Himalayan mountain range characterized by significant thrust faulting and folding. 12. What is liquefaction? The options are A. The process of a solid turning into liquid, B. a type of pyroclastic flow, C, the formation of tsunamis, D, soil turning into liquid due to earthquake shaking. The correct option is D, soil turning into liquid due to earthquake shaking. Liquefaction is a phenomenon where saturated, unconsolidated soil temporarily loses its strength and behaves like a liquid due to the intense shaking during an earthquake. This occurs when the water pressure within the soil increases to the point where it counteracts the soil's normal pressure, causing the soil particles to lose contact and flow. Liquefaction can lead to significant ground deformation, causing buildings, roads, and other structures to tilt, sink, or collapse, resulting in severe damage during an earthquake. 13. What is the term for smaller earthquakes that follow the main earthquake? The options are A, forequakes, B, sequel shocks, C, mini-quakes, D, aftershocks. The correct option is D, aftershocks. Aftershocks occur in the same region as the main earthquake and are part of the adjustment process of the Earth's crust after the initial seismic event. They can vary in magnitude and frequency, often gradually decreasing over time. Although usually less powerful than the main shock, aftershocks can cause additional damage to already weakened structures and pose significant risks during the post-earthquake recovery period. 14. Which part of the earth is primarily involved in plate tectonics? The options are A, core, B, crust, C, mantle, D, atmosphere. The correct option is B, crust. The Earth's lithosphere is primarily involved in plate tectonics. The lithosphere consists of crust and the uppermost part of the mantle and is divided into several large and rigid tectonic plates. These plates float on the semi-fluid asthenosphere beneath them, which allows for their movement. The interaction of these tectonic plates, including divergent, convergent, and transform boundaries, drive the process of plate tectonics, leading to earthquakes, volcanic activity, mountain building, and oceanic trench formation. 15. Consider the following statements in context of magnitude of earthquake and choose the correct option that follows. 1. The duration of the earthquake. 2. The depth of the earthquake. 3. The energy released by the earthquake. 4. The location of the earthquake. The options are A, only 3, B, 1 and 3, C, 1 and 4, D, 1, 2, 3 and 4. The correct option is A, only 3. The magnitude of an earthquake refers to the amount of energy released during the seismic event. It is a numerical measurement of the earthquake's size determined using the Richter scale or moment magnitude scale. Magnitude is calculated based on the seismic wave recorded by the seismographs, reflecting the amplitude and duration of these waves. Unlike intensity, which measures the earthquake's effects at specific locations, magnitude provides a single consistent value representing the earthquake's overall energy release regardless of where it is measured. 16. Which layer of the earth do tectonic plates move on? The options are A, inner core, B, outer core, C, asthenosphere, D, lithosphere. The correct option is C, asthenosphere. Tectonic plates move on the Earth's asthenosphere, a semi-fluid layer of the upper mantle. The asthenosphere lies beneath the lithosphere, which comprises the crust and the rigid uppermost part of the mantle. The asthenosphere's relative low viscosity allows it to flow slowly, enabling the rigid tectonic plates of the lithosphere to move over it. This movement drives plate tectonic processes, including continental drift, sea floor spreading, and the interaction at plate boundaries, leading to earthquakes, volcanic activity, and mountain formation. 17. What type of earthquake waves cause the most damage? The options are A, P waves, B, surface waves, C, S waves, D, none of the above. The correct option is B, surface waves. Surface waves, specifically love waves and Rayleigh waves, cause the most damage during earthquakes. These waves travel along the Earth's surface and are responsible for the strong shaking that can severely affect buildings, infrastructure, and landscapes. Love waves cause horizontal shearing motion, while Rayleigh waves produce both vertical and horizontal ground motion. Due to their interaction with the Earth's surface materials, surface waves tend to have longer wavelengths and can amplify ground motion, making them particularly destructive during seismic events. 18. Which region is known as the Ring of Fire due to its high seismic activity? The options are A. Mediterranean Basin, B. North Atlantic Ridge, C. Pacific Rim, D. East African Rift. The correct option is C. Pacific Rim. The region known as the Ring of Fire is a horseshoe-shaped zone around the edges of the Pacific Ocean basin. It is renowned for its high volcanic and seismic activity characterized by frequent earthquakes and numerous active volcanoes. This area is where several tectonic plates, including the Pacific Plate, interact, leading to intense geological activity such as subduction zones, volcanic arcs, and earthquake-prone regions. The Ring of Fire encompasses countries like Japan, Indonesia, Philippines, and the west coast of North and South America. 19. What geological feature is associated with the formation of East African Rift? The options are A. Divergent boundary, B. Subduction zone, C. Transform fault, D. Convergent boundary. The correct option is A. Divergent boundary. The East African Rift is associated with the geological feature known as a divergent boundary. This rift marks where the African continent is slowly splitting into two separate plates, the Nubian plate to the west and the Somali plate to the east. As these plates move apart, the Earth's crust thins and fractures, creating a rift valley. This process is accompanied by volcanic activity and seismic events along the rift's length, contributing to the unique landscape and geological dynamics of the East African Rift. 20. Which type of plate boundary is associated with the Himalayan region? The options are A. Divergent boundary, B. Transform boundary, C. Subduction zone, D. Convergent boundary. The correct option is D. Convergent boundary. The Himalayan region is associated with a convergent plate boundary, specifically a collision boundary. This boundary forms where the Indian plate is colliding with the Eurasian plate. The collision is ongoing and has been instrumental in the formation of the Himalayan mountain range over millions of years. The immense pressure and the compression generated at this convergent boundary have resulted in significant uplift, seismic activity, and the creation of thrust faults and folds, shaping the dramatic topography of the Himalayas. 21. Which type of fault is characterized by vertical movement where the hanging wall moves downward relative to the footwall? The options are A. Normal fault, B. Reverse fault, C. Strike slip fault, and D. Thrust fault. The correct option is A. Normal fault. The type of fault characterized by vertical movement where the hanging wall moves downward relative to the footwall is a normal fault. Normal faults form in regions experiencing tensional forces where the Earth's crust is being pulled apart. As the crust stretches and thins, the hanging wall drops relative to the footwall along the fault plane. This movement creates fault scarps and is typical of areas undergoing extensional tectonics, such as along divergent plate boundaries and rift zones like the East African Rift. 22. What are classifications of seismic zones based on? A. Economic development, B. Temperature fluctuations, C. Air pressure variation, D. Frequency of earthquakes. The correct option is D. Frequency of earthquakes. Seismic zones are classified based on the expected level of seismic activity and the earthquake hazard in a particular region. This classification considers factors such as historical earthquake data, fault lines, geological conditions, and potential for ground shaking. Zones are typically characterized from low zone 1 to high zone 5 seismic risk, guiding construction codes and disaster preparedness efforts. These classifications help communities and governments mitigate risk and ensure that infrastructure is built to withstand potential seismic events effectively. 23. What is an intraplate earthquake? A. An earthquake caused by volcanic eruptions. B. An earthquake occurring along a plate boundary. C. An earthquake that strikes within a tectonic plate. D. An earthquake induced by meteorite impact. The correct option is C. An earthquake that strikes within a tectonic plate. An intraplate earthquake is a seismic event that occurs within the interior of a tectonic plate away from its boundaries. While most earthquakes are associated with plate boundaries such as divergent, convergent, or transform boundaries, intraplate earthquakes occur due to the release of stress within the plate itself. These earthquakes can occur in areas that have ancient faults, zones of weakness, or areas where tectonic forces are still active, though less pronounced than at plate boundaries. Intraplate earthquakes can still be significant and may pose risks to nearby populations and infrastructure. 24. What is a seismic gap? A. A region with high seismic activity. B. A zone along a fault where earthquakes are less frequent. C. A site where fault lines intersect. D. A place prone to volcanic eruptions. The correct option is B. A zone along a fault where earthquakes are less frequent. A seismic gap refers to a segment of a fault line that has not experienced significant earthquake activity despite being adjacent to active seismic zones. Scientists identify seismic gaps by analyzing historical earthquake records and geologic data to predict where future earthquakes might occur. These gaps represent areas where accumulated stress along the fault has not been released, increasing the likelihood of a future earthquake. Monitoring seismic gaps helps in assessing earthquake risk and preparing communities for potential seismic events. 25. What is an earthquake swarm? The options are A. A sudden and large earthquake. B. A volcanic eruption triggered by seismic activity. C. A series of small earthquakes occurring in a localized area. D. A tsunami caused by underwater earthquakes. The correct option C. A series of small earthquakes occurring in a localized area. An earthquake swarm is a sequence of numerous small to moderate earthquakes that occur closely in time and location within a specific region. Unlike a single main shock followed by aftershocks, earthquake swarms lack a distinct main shock and may have earthquakes of similar magnitudes occurring in a rapid succession. They typically occur in geologically active areas and can last from days to months. Scientists study earthquake swarms to understand the underlying geological processes and assess potential hazards they may pose to nearby populations and infrastructure. 26. What is seismic reflection? The options are A. The dispersion of seismic waves in water bodies. B. The absorption of seismic waves by rock formation. C. The conversion of seismic waves into electrical signals. D. The bouncing of seismic waves of underground layers. The correct option is D. The bouncing of seismic waves of underground layers. Seismic reflection is a technique used in geophysics to study the Earth's subsurface structure. It involves generating seismic waves, usually using controlled explosions or mechanical sources that penetrate into the ground. When these waves encounter boundaries between the different rock layers or structures underground, they reflect back to the surface. By recording and analyzing the time it takes for these reflections to return, geophysicists can create images of subsurface features such as geological formations, faults, and potential hydrocarbon reservoirs, aiding in geological exploration and resource assessment. 27. What is seismic noise? The options are A type of seismic wave with low frequency, B, background seismic activity unrelated to earthquakes, C, multiple force shocks before the main shock, D, seismic waves generated by volcanic activity. The correct option is B, background seismic activity unrelated to earthquakes. Seismic noise refers to the background vibrations and oscillations recorded by seismometers that are not directly related to seismic waves generated by earthquakes or controlled sources. These vibrations can originate from various sources such as human activities such as traffic, construction, natural phenomena like wind, ocean, waves, and even thunderstorms. Seismic noise can interfere with the detection and analysis of earthquake signals. 28. What is a seismic cycle? The options are A seismic cycle is stress buildup leading to earthquakes, B, a geological period of volcanic activity, C, the time it takes for seismic waves to travel, D, a type of seismic wave propagation. The correct option is A seismic cycle is stress buildup leading to earthquakes. A seismic cycle refers to the recurring process of stress accumulation, release, and reaccumulation along a fault line leading to earthquakes. It involves periods of relative seismic quiescence when stress gradually builds up due to tectonic forces. Eventually, stress exceeds the frictional resistance of the fault, causing an earthquake, which is the main shock, followed by aftershocks. The cycle restarts as the fault zone adjusts through post-seismic slip and interseismic periods of strain accumulation. Understanding seismic cycles helps assess earthquake hazard and risk in seismically active regions. 29. Subduction zones are typically associated with. The options are A, transform boundaries, B, convergent boundaries, C, rift valleys, D, divergent boundaries. The correct option is B, convergent boundaries. Subduction zones are associated with convergent boundaries where two tectonic plates collide. In these zones, one tectonic plate, typically denser oceanic crust, sinks beneath another plate, either oceanic or continental crust, descending into the mantle. This process generates intense geological activity including earthquakes, volcanic eruptions, and formation of deep ocean trenches. Subduction zones are crucial for recycling of Earth's crust and mantle materials, playing a significant role in shaping geological landscapes and contributing to global tectonic processes. 30. What geological feature is commonly formed at subduction zones? The options are A, mid-ocean ridges, B, rift valleys, C, oceanic trenches, D, seamounts. The correct option is C, oceanic trenches. A subduction zone is a tectonic boundary where one tectonic plate descends beneath another, typically involving oceanic crust sinking into the mantle. This process creates oceanic trenches, which are deep, elongated depressions on the ocean floor. Trenches form at the point where the subducting plate bends sharply downward into the Earth's mantle. These features are characterized by their extreme depth and often accompany volcanic arcs on the overriding plate, marking regions of intense geological activity and significant seismic and volcanic hazards.